Good afternoon, sir.
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 गुड आफ्टरनून.
Good afternoon. Good afternoon.
अभी आप जेनेट वालों को पढ़ा रहे थे क्या लास्ट क्लास में?
हाँ.
आगे निकल गए वो लोग.
Pardon?
जेनेट वाले आगे निकल गए ना हमसे.
Hmm. What was the last thing we dealt with in the previous class?
Sir, we did a problem of NLM, the rope.
Problem, sir. Mass.
Yes, sir. The detention of a
Chain.
Sir, you told that you will give a list of problems that for NLM from IRDO.
Yes. But you will find quite a few repetitions. .59. Can you see this on this page 1.59? Which book are you having? Which publications do you have?
Sir, I have Arihant.
रुको, wait a minute. .59th problem onwards. 59.
सर बुक कौन सी है?
IRDO.
ओके सर.
Section 1.2 page 10 59th problem से लेकर 70th 59th से लेकर 73 तक कर सकते हो. 73 59 to 73 73 page number is on 13th page. Right, old version of
page
IRDO
number
if
or
you are
question
following,
number?
59th to 73.
Question number or page number?
Question
Question numbers 59th question to 73rd question.
Sir, can you show the book cover once again? Thank you, sir.
इसमें दिक्कत है कि 1 or 2 questions friction का भी है. 60th question is using friction, but you can try.
Yes.
Sir,
Right.
I have the soft copy of some Mir publications, Moscow. So,
Yes, sir, same.
but the question numbers will be the
1.2
same, right?
section Mir publications में 1.2 section से शुरू करो.
Okay, sir.
1.59 होगा problem number उसमें. 1.59 to 1.73.
Okay, thank you, sir.
Sir, this you are telling for without friction sums, right?
No, there are 1 or 2 problems with friction involved in it, but you can
Okay,
try.
and for friction you will tell later.
Sir, in the Sunday's test, will there be problems on friction?
No.
Mu is 0.2. Find the acceleration of both the blocks. Find acceleration of both blocks. Somebody is asking if mu is static or kinetic, it's the average. So you can take mu only one for both in these cases. When only one mu is given, you don't need to worry about the two. That means the difference is in the second decimal place.
Yes.
Alright?
So what are the answers? Yes, sir.
So wait.
Okay, sir.
Except for two students, all of you went wrong. Is the hint for the problem.
Okay, sir.
Sir, will you give us more 2 minutes?
Yes, I gave you the hint just now. मेहनत करो 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 मेहनत करो. ये जो टेंशन का शॉर्टकट आपको बताया गया था वो तभी अप्लाई कर पाओगे जब यू नो if the blocks are moving or not.
Yes, sir.
And secondly, G effective में friction भी लेना पड़ेगा.
Yes.
G effective is the acceleration due to all the forces acting on
Except
it except for tension. ये दोनों बात ध्यान में रखो.
Sir, if we just
Friction
solve it
कहाँ
by
पे
the
acceleration?
dynamic
दो लोग एक ही बार बात कर रहे हैं.
sir, if we just solve it by dynamic equilibrium, then we won't have to bother about it, right?
Go from the fundamental concept anytime you will be safe.
Yes.
Sir, I sent you the answer. Is it correct?
I don't know. I will not tell you.
Okay, sir.
Sir, but friction will not produce acceleration, right? So we will not consider it in the tension wala formula.
You're asking me the hint.
Okay, sir.
No hints, please. Second hint, friction is a smart force. You have to be smart to deal with it. Yes. Now listen. Let me do it in the reverse calculation so that by default you will get the proof of this. Right? I do it directly. You'll ask me, why did you assume equilibrium? How did you assume equilibrium? Firstly, let me solve. I'll assume this to be going down with an acceleration of a1, this with an acceleration of a2. I may be wrong. I'm okay with it.
Yes.
If I take tension T here, what will be the tension here?
2T.
2T.
Can you tell me the dynamic equation for this?
10G minus 2
minus
and 10 A1.
Minus 2T is equals to 10 times
That
7.
means G minus T is equal to 5G minus T.
5G minus T is equal to 5A1.
Now, this will be mg
Sin
sin
theta.
Sin 53.
60 Newton.
Sorry.
mu n.
Mu n, yes.
Yeah, yes, sir.
Mg sin 37 is how much?
60
60.
Newton.
60
Newtons.
newtons.
10 into sin 37 is 3 by
3 by 5.
6.
20 times 360.
Right? How much is mu n?
16 Newton.
18 Newton.
10 into 10 into 4 by 5. 0.2 into 10 is 2. 2 into 2 is 4. 4 into 4 is 60. So first equation will be 60 mg sin 30. Sorry,
Less
going upwards. T minus 60 minus how much is this?
16.
16.
16.
16 is equal to 10 into A2
10
is the
A2.
second equation.
Yes, sir.
Yes, sir.
A2 is 2
Yes.
A1. A2 is 2
2 A1.
A1. I need to calculate A1 and A2. I will add both the equations. 5G is 50 minus 76 is equal to 25
25
A1.
A1.
A1 is equal to minus 26 by 25 meter per second square.
Yes, sir.
Doesn't imply that this is going up. In Newton's laws, you had conveniently reversed the directions because in Newton's laws,
No
tension and normal force ka directions used to not change. In Newton's laws, I didn't have friction. It was only tension and normal force. Whichever direction the body moves, tension ka direction will not change. Normal force direction will not change. So they were the same direction. So the moment I got negative, I told you take this upwards, take this downwards, finish the problem. Not in this case, here friction will change its
Friction.
direction.
Yes.
Now if you tell me this is going up, this is going down, I'll have to reverse the direction of friction. I will have to redo the problem.
Yes.
Let us redo and see how justified the problem is, because there is a third possibility. I cannot just directly dump this case and tell you this is going up, this is going down. There is a third possibility as well. What could that be?
It
Both
is
are
not
not
moving.
accelerating.
Not
No
moving.
acceleration.
You
Yeah.
cannot
Both are
tell me there is only one case. There are two cases. Case one failed, case two is the answer. Ille. No. Have a look at this diagram. This is mg sin theta, which you are telling me is 60 Newton. Now this is T. Now I am taking this to be going down with A2. I hope this part of the board is visible. This is 10. This is 2T. This is 37. And this is going up with an acceleration of A1. Friction will be mu n in this case. See the direction of friction, it is upwards because you assumed the block is going down. Now what is your equation here? Mg sin 60, mg sin 60 minus t minus mu
Sin
n.
37.
Say sin 37. The
Sin
value 37 value is 60.
Yes.
My bad. How much is mg sin
60
37?
Newton.
60 Newton, sir.
60 minus T minus 60.
How much is mu n? 16.
16.
Is equal to
10
10.
A2.
A2 will be
2A1.
2A1.
A1 again.
my first equation. Second equation 2t minus 10g is 10a1 in my second equation. I'll make this 5 and 5, and hence when I solve this, I will get 60 minus 16 minus 50 is equal to 25 A1. How much am I getting A1?
Minus 6 by 20.
Minus
Minus
6 by 25.
By 20.
6 by 25.
6 by 25. Neither is it going down.
It acceleration is
Zero.
Nor is it
Neither
going
is
up.
this
Yes.
body going up, nor is it body going down. Then what's happening?
Acceleration
It is
zero.
at
Not
rest.
accelerating.
Body is
Equal
in
zero.
equilibrium. Could
Equilibrium.
you have solved this directly? Yes, I can. First, take it down till here. I will tell you what is the friction acting on it. Why is the game played this way? Why did this happen? Because you are taking the maximum value of friction. Friction can take any value between 0 to mu1.
Yes.
yes,
Yes,
sir.
You have assumed the maximum value and you solve, which need not be correct. Mind my language, which need not be correct. Mu1 will be the friction only when the block is just about to slide or is sliding.
Yes, sir. We did this something like this
Now,
last class
friction
also.
not only plays with the direction but also value. Here you verified both the directions. You took the maximum value. You're damn sure that neither of them is happening. Then the body is in equilibrium. I'll analyze the equilibrium situation, take it down till here.
And sir, here we assume that tension is more than the limiting value of friction, right?
I didn't assume anything. Blindly, I solved the problem using dynamic equation. The
Yes.
most
Sir,
powerful
last
of
class
it,
maybe
I made no assumptions, no bias. I kept
Okay,
my
sir.
doors open for it to go up, for it to go down. When neither of them is happening, my doors are closed. The body is at rest. Do you have any other option available? It should either go up or go down, or it should be
Or
at rest.
it should be addressed, yes.
So it is, so in this case, it is at rest, right? Because both the cases are not applicable. This is the body.
Actually, we should start from there. Problem becomes easy in one step. But if I
Yes,
start
sir.
from
Yes,
there,
sir.
you will have a million doubts. You'll ask, why did you take tension to be that value,
Yes,
this
sir.
value? Those doubts will be eliminated if I do it the backward calculation. Hence I did it this way.
Yep.
I am going to complete the
Sir, do
problem.
we have to take this down also?
Yeah, take it down. In your
So what
notes,
if
you
we
need
got
to
a-
have the difference of this to understand later on what's happening.
So if we got a positive value for A, then we can be assured that mu n full is acting, right?
Pardon?
If you got a positive value for A here, then it would be correct and mu n fully would be acting. Right?
If while solving, wherever you get positive values for A1 and A2, problem comes to an end there. That's your answer.
Okay.
While solving, I got A1 and A2 either in this or this positive. End of the story. I'll jump to the next problem.
Okay, sir.
So means if A1 and A2 are negative, then the friction changes direction. That's why the dynamic equations fail. That we
Actually,
used.
same dynamic equations won't work out. Your dynamic equations change because in this case friction was downwards. In that case friction is upwards. But Newton's laws, you told me same dynamic equations will work because tension
No
direction.
friction.
Have a look at tension here and there.
Okay, sir. Understood, sir.
Here you will have to redo the problem by changing the direction of friction.
So the static
Yes.
will be applied in this. Mu s. So in this we will apply mu s.
Mu s, naturally static friction, but we gave you only one value. That means static and kinetic here are the same. The difference is in the second decimal place, which we didn't give.
So in the case 3, then we just consider equilibrium and write the dynamic equation.
I'll come to that. Wait a minute. First take this.
Sir, sir, can you please explain once again how did you conclude that the block is not moving?
Acceleration negative आए ना यार दोनों conditions में. Neither is the block going up nor is the block going down. Then what is the only leftover option?
Okay, sir. Okay, sir.
When
Got
you get
it.
acceleration negative, you know that it is not going down. Then other option is it should be going up. Now going up also I solved, I got negative. Neither going
Okay,
down
sir.
nor going up. It should be at
Rest.
Sir, instead of solving the whole thing again, can we just put the values and then do like for the second one?
So done.
So does this say anything about the limiting value of friction?
switch off your mics. I'll explain that.
So don't have right hand side.
So done.
No, first of all, now that I know it is in equilibrium, which I should have done in the start, verification. What am I supposed to do? First of all, assume the system is in equilibrium. What will this force be? 100 Newton.
100 Newton.
T will be 100. T will be 50 Newton. And what will mg sin theta be?
60 Newton.
60,
Newton. What is the net unbalanced force on this?
10 Newton.
10 Newton
left.
Odds.
Unbalanced
Upwards.
force on this is 10 Newton downwards. This is net unbalanced force. Net unbalanced force. Friction must be up the incline. Because I know now it is in equilibrium, friction should be 10 Newton. Simple.
Yes.
If I would have
Yes,
started
sir.
the problem with this, then what will I do? I will calculate the value of limiting value of friction, un
16 Newton.
0.2
And it's greater than the F, so
into
it will
10
be greater.
into G into cos 37 is 4/5. All of you, I believe, are able to visualize that N is equal to
mg cos.
हाँ sir
mg cos theta.
mg cos theta.
That's always
This
stable.
Yes, sir, yes, sir.
This is 16 Newton. I can have friction value less than 16, greater than 0, anywhere in between. 10 is very much a permissible value. The block will not move. You should have started the problem from here. You don't need to solve the problem at all. First,
Yes.
consider the body in
Yes,
equilibrium.
sir.
Verify the net unbalanced force on it. If the net unbalanced force is less than mu n, then do not solve the problem. Comfortably tell me that the block is at rest. Sometimes they will ask you for the frictional force. Don't tell me frictional force is 16 Newton. How much is the friction acting?
So 10 Newton.
Newton.
Agree friction is a smart force.
Yes, sir.
तो सबसे पहले ये चेक कर लेना है ना कि ज्यादा से ज्यादा टेंशन कितना हो सकता है और उसके वजह से जो नेट होगा वो मैक्सिमम कितना हो सकता है. अगर वो फ्रिक्शन से कम हुआ तो ब्लॉक मूव नहीं करेगा.
Right.
So if we had started from this, then we had arrived that 10 Newton is within the limiting range. We can stop at this, right? Like we don't need to do solve for the other
Problem
cases.
is here. That's what I'm telling you.
So we have to find the tension from the shortcut that you have given.
फिर से बोलो.
अरे यार
Array body is in a free body diagram. 2T is equal to 100 Newton now.
Sir, $100 from Vinayak.
How to do this question using tension shortcut? I mean,
टेंशन शॉर्टकट बॉडी मूव ही नहीं कर रही है. टेंशन शॉर्टकट कहां से अप्लाई कर लोगे? एंड फ्रिक्शन का वैल्यू पता नहीं आपको. जी इफेक्टिव में क्या लेना है? फ्रिक्शन भी लेना है. फ्रिक्शन का वैल्यू पता है आपको?
सर अगर विदाउट
ही नहीं है,
फ्रिक्शन
variable
वाला
हो
सम
जाएगा।
मान के सॉल्व कर लो एंड देन जो मोमेंट आया उससे फ्रिक्शन का वैल्यू ज्यादा है इसलिए मूव नहीं कर म्यू एन से कम आया
हर कोई अपना अपना मेथड डिजाइन कर रहा है। आपको डिड यू अंडरस्टैंड द कोर कॉन्सेप्ट इन इट?
यस सर समझा।
बाकी आप लोग अपना डिसीजन ले लो। लाइफ इज ऑल अबाउट द चॉइसेस यू मेक, राइट? आई मेड माय चॉइस, आई वुड प्रेफर दिस।
Yes,
No,
sir.
sir.
Yes,
No,
sir.
sir.
कर लो रब कर लो।
No, sir.
Yes sir.
This is a vertical wall. You are applying a force of 100 Newton. This is a 5 kg block. Mu s is 0.4, mu k is 0.3.
Yes, sir.
Find magnitude of friction and acceleration of the block.
So you said that
मैग्नीट्यूड ऑफ फ्रिक्शन क्यों बोल रहे हो यार? डायरेक्शन भी पूछ लो ना यार। अब फ्रिक्शन का डायरेक्शन इसमें कोई नहीं पूछेगा क्योंकि आपको पता है एक ही डायरेक्शन होगा। फ्रिक्शन
अपवर्ड्स होगा,
राइट? 5G is acting downward. So friction का डायरेक्शन मुझे पता है, it will act upwards. Tell me the magnitude and acceleration.
so mu s and mu k are the static and kinetic friction, right?
Mu s is coefficient of static friction, mu k is coefficient of kinetic friction. You are verifying if I am alert or not.
No, sir. No, sir. You said that the difference between them comes in the second decimal place.
Here it's not, hence we gave different values.
Okay, sir.
There's one more important announcement for all of you. Tomorrow's lecture will not be a doubt lecture. For you, assignment 3 doubts are cleared, right?
Yes, sir.
Yes, sir.
A regular class for you, and something very important in friction will be taught tomorrow.
The
If
sliding
you
and
miss, you are in soup or you're in trouble. So please attend tomorrow's lecture. Is that clear to all?
Yes, sir.
Yes, sir.
friction will be taught.
Sir, what if we have booklet doubts?
Booklet doubts.
Sir,
booklet
booklet
we
you
had
had
only
only
given
given 10
10 questions. You can take in
questions.
the last 20.
Yes, sir.
last-
Or you can
yes,
take it in the
sir.
next class. Once you give the additional homework, you can take all of them together.
Okay, fine. That sounds better. Now listen. 5G is acting downwards. If you draw the free body diagram, the external force of 100 Newton is acting this way, and this is the normal. Normal force should be equal to 100 because the block
Yes,
is not
sir.
accelerating.
Yes.
So frictional force I will calculate mu s into n first.
Yes, sir.
0.4
40 Newton.
into n is 100. This is 40 Newton. While how much is mg? 50 Newton. So 100% the block will be sliding downwards.
Yes, sir.
Yes.
I know it is sliding downwards. I'll bring mu k into n into picture. 0.3 into 100. 30 Newton is the frictional force acting on it. How much is the frictional force acting on the block? 30 Newton. What is the acceleration of this? 50 minus 30 divided by
4
5.
meters per second.
20 by 5. 4 meter per second square is the acceleration of the block in the downward direction.
Yes.
So the magnitude of frictional force will be 40 or 30 or both. What will it be?
Obviously 30, block is sliding. Magnitude of the frictional force will be 30, block is sliding.
Okay.
If the block was not sliding, 1 second, all of you listen. If the block was not sliding, what would the magnitude of frictional force be?
Equal to F.
No, sir. Equal to the
Equal
weight.
to the force applied.
of the body.
Equal to mg. If
Yes,
the
sir,
block
weight
is
of the
not
body.
sliding, if suppose mg, this is suppose mg is 20 Newton. Now what will be the same? Mu s is 30.
20 Newton.
20 Newton.
Sorry, mu s is 40 Newton. Mu k is 30 Newton. What is the frictional force acting?
20 Newton.
20
Newton.
So if mu s ne comes up here, even when it is sliding, it will not come into picture. When it is at rest, it will not come into picture. It is only to decide if it slides or not. When the block is not sliding, frictional force will be equal to the external force.
Yes,
sir.
Yes.
Now, on the contrary, listen, one more example then. We'll make it a bit more complicated. Suppose if mg was 35 Newton. Mu s is not 40 Newton. Mu s is 0.4. How should I call this?
Static friction is
Force limiting static. Frictional force limiting kinetic. Now, frictional force limiting static is 40 Newton. Frictional force limiting kinetic is 30 Newton. Now, by the way, will the block slide or not?
No, it won't.
It won't.
Sir,
It won't.
Sir, it won't.
35 Newton.
35.
Newtons. Frictional force acting is 35 Newton.
Yes, sir. 35.
Till I reach 40, whatever is the friction, mg frictional force will be that.
Yes.
Yes.
If it is equal to 40, block was at rest, it will continue to be at rest. You cross 40 here,
The block
friction
Block will accelerate.
decrease to 30. I cross 40 here. If the weight is greater than 40 Newton,
Yes, sir. Yes.
friction will immediately decrease to.
30 Newton.
30.
Are you
Sir, we
following?
even understood.
The 45
That's
has
understood.
The moment weight crosses 40, the block will slide. The moment it slides, friction will not remain 40 anymore. It will fall down to
30 Newton.
30.
take
Sir, we
down.
even understood this through that graph.
Yes, sir. Right, you can see the
Yes,
graph
sir.
as well. Yeah, fair enough.
So, but if the weight is 40, then the friction will be 40, right? Because it is equal to the, yeah. Yes.
Block is at rest.
Yes.
So if the weight is more than 40, the static friction will only after a split second. After that, it will drop to 35.
Yeah. It will be in microseconds. You don't need to worry about it. That they will never touch.
Sir, can you tell
If
what?
it is 40, if it is 40, it will be 40. Block is at rest. Frictional force will be 40 if the weight is 40.
Okay,
Block
sir.
is at rest. The moment it crosses 40,
Friction reduces to 30.
friction force is immediate.
Okay.
Sir, can you tell what does LS and LK stand for?
Limiting static friction, limiting kinetic friction. Limiting value इसीलिए बोल रहा हूँ because you are taking mu n. Mu n is the limiting value of friction, maximum value of friction.
Sir, when the body starts sliding down, friction will be mu k n, right? Okay.
Yes, sir.
Yes.
The force that you are applying is not horizontal here. It's making an angle of 37 degrees with the horizontal.
Yes, sir.
Yes, sir. Give us 2 minutes.
Right? Mass is 12 kg. Think carefully and solve the problem. I need direction of friction, magnitude of friction, and acceleration.
Yes.
Find friction and acceleration acting on the block. Quite a few of you have got the answers correct. Only one student is typing acceleration is 0. That's wrong. It will have acceleration of 5 meters per second square. Friction is 120 Newton.
Yes, sir.
So kinetic friction is 120 Newton, right?
Kinetic friction.
Yes, sir.
So can you repeat the answer for acceleration?
Acceleration is 5 meters per second square and frictional force is 120 Newton.
Yes, sir, good.
Yes.
Here you will resolve the forces.
Yes.
100 Newton ka, if 500 Newton is acting this way, this angle you gave me as how much?
37.
30.
Did I take it properly?
Yes.
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 Sir.
Now 500 sine 37 and this will be 500 cos 37. 500 into 4 by 5 will be 400 Newton in the horizontal direction. 500 into 3 by 5 will be 300 Newton in the vertical direction. Are you trying to tell me that this force in the upward direction is 300 Newton? This force is 400 Newton. That means the normal force will be 400 Newton. mg is how much?
20 Newton.
120.
120 Newton. Frictional force. Now 300 is greater than 120. So technically friction will act downwards.
Yes, sir.
300 is greater than 120. Unbalanced force is in the upward direction. Static limiting friction is μs into n. How much did I give you μs? 0.4
160
into
Newton.
400. This is
160
160
Newton.
Newton. 120 plus 160 is 280. External force is
300.
So block is sliding.
Yes, sir.
Once it is sliding, I will dump this friction. I am not interested in this value anymore.
Yes,
You
sir.
take this value, you are in soup.
Yes.
Once I know it is sliding, I am supposed to take kinetic friction. 0.3
120 Newton.
200
120
is
Newton.
120 Newton. Force in the downward direction is 120. So frictional force acting, I will report 120 Newton. Acceleration 300 minus 240 divided by 12 meter per second square. So far, so good.
Yes.
Done, sir.
So done.
Yes.
Yes, sir. Got it.
This is a string and this is a block. I am pulling this with a force of F. if the force of F is less than mu mg, is less than mu n, this is n, this is mg. If the force is less than the mu mg value, then this is case 1. This block will not tend to move ahead, right? It will be at rest.
Yes.
Yes,
So
sir.
tension in the string will become 0.
Yes, sir.
Yes.
Case 2. If friction is equal to mu mg, force is equal to mu mg, friction will be balancing that, even then the tension
Yes,
will
sir.
be 0. Case 3. If force is greater than mu mg, now draw the free body diagram. This will be mu mg. You have a tendency to move this to the right. Now tension will come into the picture, right? Your equation will become F is T plus mu mg. So T, if you are asked, it is F minus mu mg.
Yes, sir.
Suppose you tell me that breaking stress in the string is T naught. Breaking stress is T naught in the string. If the tension becomes greater than T naught, the string will break. Greater than or equal.
Yes.
So now verify if T is greater than T naught. Small n accelerates. It will accelerate to the right. T is less than T naught. Small m is at rest. If the tension in the string is less than the breaking stress of the string, body will remain in equilibrium with these two forces balancing this. But if the tension here becomes greater than T naught, string snaps, body accelerates to the right. With how much acceleration? F minus mu mg divided by m.
Yes, sir.
Yes, sir.
Yes.
I have a very bad habit of writing acceleration as ACC, which is not a standard abbreviation for acceleration. I can afford to be lazy, not you. Please write the complete word here. Is that clear?
Yes, sir.
Yes, sir.
Sir, like when it breaks, when the string breaks, so T naught will be acting right at that point. So
String breaks
There
के
is
बाद
no
T
string
naught
now.
कैसे act करेगा?
no, the second it breaks, won't T naught act?
जब टी नॉट
वो
अटैक नहीं
split
करेगा
second
वही
वाली
ब्रेक
चीजें
करना
useless
होता है
है,
ना।
उन्हें कैसे account करोगे?
ये टेंशन से इतना लगाव क्यों है मैडम आपको? पर ए सेकंड एटलीस्ट लेट इट एक्ट सर। हद हो गई, उस टेंशन नहीं है, स्ट्रिंग ब्रोक, लेट इट गो।
अच्छा।
Done, sir.
Sir,
Wait, sir, wait.
sir, sir, as soon as the string breaks, won't the acceleration of the block will become suddenly very high and then it will decrease?
But you don't worry about the transition. They will not touch that. Transitions will always be key. This we will touch. This concept will again touch in impulses. Cutting a string के लिए अगर आप Irudov का problems देखेंगे, he will never say that the string breaks. He says the string is burned. There is a difference between the two. When you cut, you are exerting an impulse on it. When you burn it, it is a smooth transition.
Yes.
Yes.
Temporarily don't get
Oh.
into the things, still I teach you impulse. Which was
Sir,
and stop using this colloquial language. Somebody typed, when it breaks, won't there be a jerk force? Physics may, we don't call it jerk. We call it impulse.
Impulse.
Is that clear?
Yes, sir.
This
Yes, sir.
language is unofficial. Right?
sir, jerk is the
Yes.
derivative of acceleration, right? आगे है.
थप्पड़ मारूंगा. Physics में वो impulse बोलते हैं. We don't call it a jerk. Jerk is colloquial language.
But sir, isn't there some kind of force of meter per second cube that is called jerk force?
कहाँ से लिया आपने यार ये सब? Now solve one simple problem. This is MB, this is MA. This angle is 37 degree. पूरा क्लास में आज सिर्फ 37 डिग्री ले रहे हैं ना यार.
Yes, sir.
हाँ,
Sir, 60 degree दे दो.
हाँ, sir.
53.
नहीं it's so.
अरे सर यही
सर नहीं चाहिए एयरपोर्ट्स आ जाएंगे ये बहुत अच्छा है 37
सर 90
हाँ सर 37 53 अच्छा है.
37 और cos 37 का वैल्यूज तो याद रहेंगे.
हाँ सर.
हाँ.
सर
Yes, sir.
37 is the best. तो 60 में फिर √3 आता है.
MA
हाँ,
by
वही.
MB if the blocks just start moving. Just start moving. Find MA by MB if the blocks just start moving.
Yes, sir.
11 by 5
Sir,
is correct.
Yes, sir.
Yes, sir.
Some students are typing 8 by 5. 8 by 5 is wrong. This is
सर वो
t,
लोग का 1 मिस हो गया होगा.
t plus n plus t sine 37. This will be t cos 37.
Yes.
T is mb into g. T is mb into g is my first equation. Just starts moving. So equilibrium condition. This should be equal to mu n. T cos 37 is equal to mu n, and n is not equal to ma into g. N plus t sine 37 is equal to ma into g. Substitute this n here.
So we won't take the acceleration here.
It is just
Equilibrium. Just start
moving
moving. Yes.
equilibrium here. Acceleration is tending to 0.
Sir, what is the final answer?
11 by
11 by 5.
Sir, N is the normal force, right?
You have any other proposal?
No, sir. No, sir.
Where? क्या वेरीफाई कर रहे हो? मैं अलर्ट हूँ कि नहीं?
नहीं सर, इस तो हमने नॉर्मल फोर्स को क्यों लिया इस इक्वेशन में?
तो mu n कैसा लोगे? Frictional force limiting value कैसा लोगे? Just about to slide तो friction has reached limiting value.
Yes. ठीक.
Done, sir.
Yes, sir. Done.
What is the maximum force with which the man can pull the string so that the plank remains at rest? Write down the statement. What is the maximum force with which the man can pull the string? What is the maximum force with which the man can pull the string so that the plank remains at rest?
Sir, after so that.
Not so that, so that, S-O.
After so that.
So that plank remains at rest. So that, right?
Yes, sir.
Yes, sir.
So that Planck remains at rest.
Sir, there is no friction between Planck and man.
Come again?
There is no friction between Planck and man.
There is no friction between the man and the Planck. There is only friction between the Planck and the ground. Your answers will be in terms of mu, small m, and capital.
So man.
Man.
Sir, in what way should we write the answer and using which
In
variables?
terms of mu, small m, and capital M.
Okay, sir.
People are reporting the answer as mu, small m plus capital M into G. They are wrong. Maitri gave the correct answer. Aina Mandal has given the correct answer. Aina Mandal, how do I pronounce your name? Ayana.
So it will be like Ayana.
Ayana.
Yes, sir.
C. Lakshmi gave the correct answer. Tanish is correct. Arene, enumerate mu. Okay, you are typing MEW as mu. Mu. Okay. Listen, quite a few of you are typing your answers. Quite a few of you are correct. Listen, when you draw the free body diagram here on the man, this will be normal force and this will be T. This will be capital Mg. Free body diagram of small m draw kar raha hu, dhyan se dekhiye. Reaction of this normal force I'll have to draw
Yes.
here. This is small mg. This is T. This normal force I'll call it as M0. This will be
Mu m. Mu.
This normal force is the normal force at this surface.
Yes, sir.
Call it M0. So friction is mu M0. Reaction of this normal force on this small m, I draw it in the downward direction. Force applied by the man on the string is the tension in the string. We have done
Yes,
this
sir.
in Newton's law. You pull the string with a force of F, string will pull you with a force of F. So force applied by the man on the string is the tension in the string. So this is T. So when will this block start moving if tension is equal to mu n naught? What is n naught equal to? Mg plus n.
mg plus n.
But then n is not equal to capital Mg. N plus t is equal to capital Mg. Man is not accelerating upwards. So n is mu mg plus mu. N is capital Mg minus t. That is the key catch in it. Where many of you might have gone wrong is you might have taken n is equal to capital Mg.
Yes, sir.
Now mu t, I pull it to the right. It is 1 plus mu is equal to mu mg plus mu capital Mg. Bring this to the denominator. That is the tension in the rope for which the plank is just in equilibrium or just about to slide. Tension greater than that, it will start slide. This is the maximum force the man can apply for the system to be in equilibrium.
Yes, sir.
So the final answer is mu mg plus mu capital Mg upon 1 plus mu.
You are verifying if I can bring this to the denominator.
Yes.
जो emphasize करके पूछते हो तो मुझे डाउट आ जाता है यार. T is equal to mu g into small m plus capital M upon 1 plus. I can afford to be lazy. Last step मैंने छोड़ दिया तो doesn't mean you will forcibly make me write that.
Done, sir.
No, sir. Wait.
Done.
All surfaces mu is 0.25. Find the force to be applied for capital N to move with uniform velocity. Find the capital F for which capital M slides with uniform velocity. Draw the free body diagram properly.
Sir, so that mu also acts between the two objects.
Yes, all surfaces इसीलिए लिखा है मैंने. Mu is between small m and capital M, between capital M and ground. I gave arbitrary numbers. I don't know the answer. So don't type the answer. I'll solve it. When you draw the free body diagram for this is tension. First of all, you're pulling with a force of F. This block will be sliding to the left. Friction is very loyal to the surface
F1,
over
F.
which it acts.
Yes. Yes.
This will be N1.
N.
This will be 4G.
4G.
Reaction of this friction on this will be in this direction. This is the key catch.
Yes, sir.
Reaction of this friction on it. What makes you say that on this friction will be in the backward direction? You are making the block move ahead. Friction will do everything possible to keep the block at rest.
Yes.
To prevent sliding between the two. On this friction will act backwards. On this it will act forward. Action, reaction. How much is this one? F1. It will be 0.25 into 4G.
10 newtons.
10 Newton.
F1 is 0.25 into 4G. This is 10 Newton. Now, reaction of this normal force on this is in the downward direction.
80
Newton. Is in the downward direction. N2 is in the upward direction. This is mu N2.
30.
Mu N2 will be 0.25 into N2 is
12G.
N1 is 4G.
N1 is N1 plus 4G, 0.25.
So N1 plus
8G, na sir?
N1 plus
8G. 4G plus 8G is 0.25 into 12G. This will be 30 newtons. Right? So how much force should I apply? 10 plus 30
40 Newton.
40 Newton.
equal to 40 Newton for the block to be sliding with uniform velocity.
Yes, sir, I have a doubt. Will pseudo force not act on the upper block?
Solving everything with respect to ground. If your observer is standing here, then you think of pseudo force. With respect to ground, no pseudo force.
Okay, sir.
So then how will it be when, if we take pseudo force?
If you are standing here, find the acceleration of this, but here acceleration is 0.
There is
So
no
will it
acceleration.
become-
Yes, sir.
There is
So
no
pseudo force will be-
acceleration. No, sir.
Exactly.
Why pseudo force we have to bring?
So can you explain that part of sir, the upper block, sir, why the friction is up?
Action, reaction. On this, why friction is in the backward direction? You are pulling the
Sir,
block.
that I
तो इसका रिएक्शन, एक्शन रिएक्शन, सो F2 का रिएक्शन क्यों नहीं ड्रॉ किया यार आपने? ग्राउंड का फ्री
Ground
बॉडी
पे
डायग्राम
लगे।
ड्रॉ नहीं किया हमने। अगर ड्रॉ किए होते तो F2 रिएक्शन ऑन द ग्राउंड विल बी इन फॉरवर्ड डायरेक्शन।
So
Sir, if the force is more than 40 Newton, then how will be the motion of the both the blocks?
That is called acceleration.
No, but like the block of 4 kg won't move, no, only 8 kg block will move, no?
No.
And
No.
the
8 kg will be accelerating with F minus 40 divided by 8.
okay, I had a doubt in that only, if it is divided by 8 or something else.
Sir,
That's why we split the free body diagram separately, so that you will be able to see clearly what happens with 4 and 8.
Yes, sir. Thank you.
sir, here F1, F2, and the capital F are cancelling each other, so the block will remain at rest, right?
If it were at rest, it will continue to be at rest. If it is moving with uniform speed, it will continue to move with uniform speed.
Sir, can you explain why the F1 is in right hand side and
This
the lower
block is
bound?
sliding ahead. This block is sliding ahead. Friction will oppose it.
Yes, sir.
So opposite should be in the backward direction.
Okay, sir. Okay, understood.
Done, sir. So what we have to find?
Find the force F so that 8 kg block is sliding with uniform speed. Find the force F so that the two blocks are moving with uniform speed. Find F so that both the blocks are moving with uniform speed.
Yes.
So today you'll send an assignment.
I need one more lecture here. If not, only one part of that assignment you can solve. Probably tomorrow's lecture ke baad I will send.
Sir, find F so that
Both the blocks move with uniform speed.
सर फ्री बॉडी डायग्राम में वर्टिकल फोर्सेस ड्रॉ करने का जरूरत नहीं है ना?
चाहिए वरना फ्रिक्शन कितना मिलेगा?
सर वो तो अलग से सोच सकते हैं।
फ्रिक्शन कैसा
force के लिए
मिलेगा?
normal force चाहिए।
So same thing, uniform velocity.
Yeah, uniform velocity. This should be moving to the right. This will be moving to the left. You're pulling this. So if this is moving to the right, friction on it will be backwards.
Yes.
Moving to the left, friction on this will be in
Yes.
this direction.
Yes.
Now N1 is equal to 4G. That I am sure of. N1 is equal to 4G. So N2 will become 12G.
12G.
N2 will be 12G. Now
Yes.
here this is moving with uniform speed means tension will
T
be
is
equal
equal
to
to
F1.
F1.
How much is F1 equal
10
to?
Newton.
10 Newton.
Newton.
0.25 into 4G.
10 newtons.
10.
F1 is 10 Newton. F2 is how much?
30
0.25
Newton.
Newtons.
How much is this?
30
30
Newton.
Newton.
30 Newton.
And T is
T
equal
equal 10
T
Newton.
is 10 again. 50 Newton.
T is equal to 10 Newton. So the force to be applied is
50
10
Newton.
plus 10 plus
50 Newton.
30, 50 Newton for the blocks to be moving with uniform speed.
Yes, sir.
Yes.
Sir, F1 will act opposite because it's on different bodies, right?
Say that again.
The F1 of the upper block, I mean, on the down block will act in
And
the
action
opposite direction.
reaction pairs.
Yeah,
They'll be in
okay.
opposite direction. Action reaction pairs. They
Sir,
will be
why is tension equals to F1?
for this block to move with uniform speed, this force should be equal to this force. If tension is greater than F1, it will accelerate.
Okay.
So by taking F2 to the right, we are assuming that the capital F is greater than F1 plus T, right?
Actually, if not, it will not move. If capital F is lesser than sum of these three by any chance, it will not move it.
Yes.
So uniform velocity is asked, so that is implied.
Yeah. So the same value of capital F I would report if either you ask me for uniform speed. See, if you remind my language, I said uniform speed, not velocity.
Yes, sir.
Yes, sir.
Opposite direction.
Yeah.
This is this direction, this is in this direction. That's why I didn't say uniform velocity. Both will not have the same velocity under any circumstance.
Yes, sir.
Yes.
Something important need to be covered. Are you people ready to receive?
Yes, sir.
So,
Yes, sir.
People who feel we are tired, raise your hands. The worst part of this class is last half an hour, 20 people will bunk the class.
Sir, then it is their fault.
People are raising hands.
सर 150 में से 10-15 बच्चे अरे बढ़ गए
हाँ, सर।
अरे बाप रे बाप
सर चलेगा ना मतलब मेजॉरिटी
Majority.
अरे सर
मेजॉरिटी विंस
बहुत बढ़ते ही
सर 5 मिनट का
बढ़ते ही जा रहे हैं
सर जान
5 मिनट रुकेगी पूरी क्लास आ जाएगी
और
5 मिनट
सर बढ़ते जा रहे हैं
सर 5 मिनट का ब्रेक दे दो
हाँ सर ब्रेक दे दो
नहीं
अरे
सर
सर बढ़ते ही जा रहे हैं
सर 25 मिनट और है।
मत खाना खाते खाते
सर
अटेंड
क्या
करते हैं
मजा
सर
आती
कोई
है
जरूरत नहीं है
Okay.
बैठ तो आप जीकेएम सर जैसा करो
No, I
डेमोक्रेसी
सर
understand.
मैथ्स का भी डाउट्स ही था आज।
सर खाना
हाँ,
खाते
सर।
खाते अटेंड करते हैं
Thamba. Cool. We are in a hurry to complete
तो
syllabus.
20-25 बच्चे ही होती है
It's okay.
सर एक्स्ट्रा क्लास ले लो
ऑलरेडी 20 लेफ्ट द क्लास आप लोग इनकी
Yes.
सर रात को रख दो 9-10 बजे मजा आएगा।
So 165
हाँ,
से
sir,
160
को 9:45 करो।
सुन लो, there was a time in pace when we used to have a night class where the class used to start at night 9:30 till morning 5:30.
That's the best.
Day night.
एक दिन मजा आएगा।
Who came to that class, sir?
ये तो बेस्ट चीज है। This was in the year 2007-2008. रात को 12 बजे अंधेरी के पास थे तो मैकडी से we used to order 11:30 MACD used to close. So last order we used to order from MACD, have 1 hour of a break and then continue till night 3 o'clock. अंधेरी स्टेशन के नीचे we used to get tea. So all kids के लिए we used to order tea and morning 5 तक we used to have a class.
सर तो पोर्शन
मस्त है
But why? Why?
Sir, that sounds very nice.
An advantage.
हम लोग के साथ भी करो
जाते होंगे ना एक क्लास में।
Contact with the kids. So we
सर
could
आप पोर्शन स्लो चलाओ लास्ट में ऐसा करो ऑफलाइन जब चालू होगा तब।
अरे
ऐसा नहीं करेंगे
Sir,
पोर्शन स्लो चलाना बेकार है।
Sir, but why did pace do
we
this?
will go at the same pace, nothing to worry about. Important, listen. Important, tomorrow's class will be important and heavy. Please come mentally prepared. Tomorrow
Sir,
is
क्या
not a doubt lecture for you people. Listen carefully. It's not a doubt lecture for you people. It's a doubt lecture for Zenith batch, not you people. So please come mentally prepared.
Yes,
सर
sir.
कल क्या
Yes,
पढ़ा
sir.
बताओ ना।
But why did they do it like that?
But why did this?
Yes, sir. Yes, sir. Why night
पर
class?
इतना रात को
Those days, PACE did not have a junior college. PACE Junior College started only after 2009. So students used to go to different colleges and evening they used to come to us. So every alternate day, evening 6 to 8 only we used to have a class. So then completing syllabus was difficult. So then we used to tell them colleges used to have उनके own exams, college exams. वो college syllabus HSC textbook पढ़ाते रहेंगे, उसमें से projects देंगे. So kids used to be held by the college. नहीं जाएंगे तो college attendance was mandatory. So then to complete the syllabus, we were under pressure. We used to call them even during Holi and Diwali. So then बीच में एक दिन night out we used to do and swing में एक chapter खत्म कर दी.
Sir, it fun
सर
होता
करो ना एक बार
हमारे साथ ऐसा कर सकते हैं।
लगाओ ना ऐसे ही
यहाँ पे लोग
सर ऐसे फ्रिक्शन खत्म कर दो एक दिन में सर ऐसे ही फ्रिक्शन खत्म
सर
कर
एक
दो
लेते हैं ना क्लास
सर एक का solution।
मेरे लिए क्या खत्म करने के लिए खत्म कर दूंगा, खत्म आपको करना है मुझे।
एटलीस्ट एक बार तो कर सकते हैं ना, मतलब एक्सपीरियंस के
सर इतना लंबा नहीं बट थोड़ा तो ऐसा
ऑनलाइन
जूम पर करने में मुझे एक दिक्कत है, कितने लोग सुन रहे कितने लोग सो रहे मुझे पता
सर
नहीं।
वीडियो ऑन करवाना
सर वीडियो ऑन नहीं कर सकते
ऑन करवाना सर
वीडियो ऑन कर सकते
जिनको बंद करके करना है वो कर।
Before rotational dynamics, we'll plan for it. Pandit.
यस सर यस
Thank you so much, sir. Sir, thank you. मजा आ गया।
मजा आएगा
आ जाएंगे सर
Okay.
sir.
Good day. Bye.
बाय सर थैंक यू सर
थैंक यू
कल आप